Hello, I'll be talking about fiber-reinforced polymer, and my name is Isabel Dosi Tawashima. Now, the content, I'll be discussing the introduction, literature review, research design, laboratory test results, limitations and conclusions of this research. But first, what is fiber-reinforced polymer? Fiber-reinforced polymer are composite building materials such as rice hooks, glass, carbon, wood, and many others. Because of their material properties, they have been used to improve fracture toughness, structural buildings, and bridges. There have been various structural failures and building members' maintenance concerns. And this study will assist in providing solutions to this concern. Now, talking about the gaps in this research, there have been a substantial total number of current experiments on FRP concrete confinement, that is fiber-reinforced polymer, which have failed to take responsibility for the impact of internal, longitudinal, and transverse steel reinforcement. Researchers have come up with a few contradictory and more consistent conclusions. The purpose of this research is to analyze the axial stress strain capacity using test variables in order to evaluate pre-damaged columns using the proposed updated confinement models accuracy from Zhenhu's research in the literature review for the test specimens with different material and geometric properties. Now, in the literature review, the two major used polymers are the carbon and glass fiber reinforced polymer with their polyester material property. The first figure shows the glass fiber reinforcement bars, and the second shows the concrete filled fiber reinforced polymer, that's the FRP tubes, in general, the CFFTs, which is made up of carbon fiber sheets. Both fibers have shown increase in the compressive strength of columns significantly. Now, the research question in this report, I will be answering this question. What is the axial stress strain capacity of pre-damaged reinforced columns and confined with carbon fiber reinforced polymer using different materials and geometric properties? Next is the research design. In this research, about 90 CF carbon fiber reinforced polymers, that is CFRPs, that is both circular and square, will be mounted, manufactured, and checked, subjected to a monotonous and tedious routine, as well as multiple loading scenarios of cyclic compression. Though this report will present the findings from 40 of this CFRP, because they'll be chosen in order to compare the component and cross-sectional properties of CFRP. Now, different stages of pre-damage loads are requested and presented. And these samples, which is the D1 and D2, will reflect the most extreme situations for these samples. Now, these samples, it is the way we investigate it is that they'll be subjected to different levels of loading before application of CFRP wraps, which is the carbon fiber sheets polymer. Such pre-damage will then be applied by cycling and compressive axial load by 5 times the pressure, reaching up to like 40% for D1 specimens and 80% for D2 specimens. Now, this is the CFRP laboratory test equipment, the LVT, which is the linear variation differential transformers, measures the axial stress strain capacity. The results will help in finding the causes of structural failures, maintenance of buildings, and measures the deformation in columns. Now, the result, the axial strain capacity of CFRP sheets has significantly increased. The initial damage, however, had only a minor impact. Limitation, it is noticed that the physical deformation is likely to occur after placing under different levels of loading before the application of CFRP wraps, affecting smooth and evenness of wrapping. In conclusion from the investigation, reinforced column confined in CFRP shows increase in axial stress strain capacity significantly. Prior to the initial damage, it had only a minor effect.